Bismillah ar-Rahman ar-Rahim. In this lecture, you will learn about the first law of the thermodynamics and the very brief equation associated with the first law of the thermodynamics. And I will explain about the different terms over here, the delta E, Q, and the work, and what would be the explanation in case of the first law of the thermodynamics. So the first is very simple explanation of the first law of thermodynamics, which is based on the conservation of energy law. And this is the energy cannot be created and cannot be destroyed, but it can only be converted from one form to another form. So this is the law of conservation of energy, and the first law of thermodynamics is based on this law. And if I want to restate the first law of thermodynamics, that means by considering the law of conservation of energy, that means the total energy, total internal energy of an isolated system is constant. That means if this is the system, and the system, as you know in the previous video, but briefly, the system is the whatever the area or the study under consideration, that is called the system. And here, if the reaction is going on and the reactants and the final products are collectively called the system, and outside of this system, everything is called the surrounding. So the total internal energy of the system, that means whatever the energy of this system is, it will remain the constant, and this is according to the first law of thermodynamics. And if you want to calculate the internal energy, this is the internal energy in the energy of the system, which is inside of the system, that is called the internal energy. And internal energy you can calculate by using this expression, and delta E will be equal to Q plus W. This is the mathematical representation of the first law of thermodynamics. And this is the delta E. Delta means the change in the internal energy, and the change in internal energy you can calculate by using very simple, the difference between the energy of the final minus energy of the initial. So what would be the difference in energy that will give you the change in the internal energy. But here we are discussing the mathematical expression of the first law of the thermodynamics. That means delta E, which is the internal energy, is equal to the energy absorbed or energy released, that is the Q, plus it is the work done. So the delta E is the change in energy, and Q is the heat transfer, and it may be positive or it may be negative. So when it is the having the value in positive, that means the system gains the energy, and it is given over here. And that means if this is the system, and system is gaining the energy from the surrounding, then it it is having more energy. That means the energy of the system is increased, and this is represented by the plus sign. So energy is entered into the system from the surrounding, then the Q is having a positive sign. Actually this positive sign is representing the Q. And vice versa, if energy is released from the system, then the sign of the Q will be the minus, and it is given over here, and I have explained in this diagram. So you must remember when what are the condition for the positive sign and the negative sign, or the energy is energy into the system or energy out of the system. And this is the work done. In the later slide, I will explain in detail actually how can you calculate the work in case of the expansion or the contraction according to the first law of the thermodynamics. And generally here we are discussing the ideal behavior or of the ideal gases. So let's move to the first description about the Q, and then I will explain about the W. So because this is the mathematical explanation, you have to calculate the delta E. And there is another equation in some books, it is given, and this is the same. If delta U is given, that means it is the same as the delta E is having, just there is this different symbols in some books or some literature they are using, but the explanation is the same. Delta E or delta U are the internal energy. Again, small q or the capital Q are the energy absorbed or energy released. And again, small w or the capital W is the same thing. This is the work done. So don't be confused when you see these different equations in different books. So these are the similar. So the first is the heat transfer. So heat transfer is the Q, and there are the two ways. One is the, again as I have explained before, this is the system. If the system release the energy, and this is the enthalpy, what is the change in energy over here, energy released or energy absorbed by the system, and that is given by the change in enthalpy. This is at some constant pressure, but later in the next lecture I will explain delta H according to in terms of the thermodynamics. But here it is not the question over here. This is the simple. If heat is released, that means this is the energy is increased from this to this level, and if the system is releasing the heat, that means the system before the reaction is at the higher energy level. That's why the system is having more energy, and this is going to release the heat. That means before the reaction the system is having more energy, and then it is going to release the energy, and that this is the system after the reaction. That means if these are the reactant and this may be the product. So before the reaction, that means the reactants are having more energy, and after the reaction the products are at the lower energy. So what is happening over here, energy is released from this to this point, and this is explained by using very simple diagram over here. The system is releasing the heat to the surrounding, and the sign of this change in enthalpy, because this is the delta H, this is the delta H, so change in delta H would be less than 0. That means the sign would be minus. So if the sign is minus, that means the energy is released from the system to the surrounding, and these type of reactions are called the exothermic reaction. Exo mean exit, and thermic mean the heat is being released from the system, and that's why these are called the exothermic reaction. And the other reactions are the endothermic reaction, opposite to the exothermic reaction. If the system gains the heat, that means the reactions are called the endothermic reactions. So here again the energy is going to increase in this way, but opposite to here, this is the system before the reaction. That means reactant at lower energy, because here we are considering the system as a reactant and the product. So before the reaction, that means the reactants are at the lower energy. When system receive or gains the energy of the system increased, and this is the system after the reaction. And the difference between these two H, that is called the delta H, and the sign must be greater than 0. That means it is the positive value. Greater than 0 mean it is having the plus value or the positive value. So this is the explanation of the Q. When the Q is having the sign minus, that means it is the energy release from the system, and when the Q is having positive sign, then the system is receiving or the gaining the heat from the surrounding, and these reactions are called the exothermic reaction and the endothermic reaction. Now moving to the work, because in the equation, we have the Q and the other one is the W. If the you know the W and the Q, you can easily calculate the change in the internal energy by using this mathematical expression. So what is the work? So work over here is defined as the force that produces the movement of an object times the distance moved, that is the d. So simply the work is the force into displacement. If you are going to apply some force and there should be a displacement, that means the work is done. So this is called the work. But here we are considering, let's suppose this is the reaction, all these are the gases, these are the this is the propane plus 5 molecules of the oxygen forming 3 molecules of the carbon dioxide and 4 molecules of the water in the gaseous form. So 6 moles are converted into the 7 moles. So before the reaction there was the 6 moles, after the reaction there was the 7 moles. So number of moles are increased. So this is the before the reaction where there are the 6 moles of the gas collectively are there, and then the number of moles of the gas are increased. That means no, the reaction is going on. So after the reaction there is the more number of moles of the gas. Now the there should be a expansion as compared to this point. This was the initial stage as given over here. So by increasing the number of moles, this piston moves up, and now there is the force is being applied over here to uh, 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 to move with the distance d, and this is called the work done. So I will explain the next slide, but here important over here is in terms of the expansion, what is happening over here, there is some internal pressure, because the internal pressure is more, which is going to actually repel to the external pressure, and that's why the expansion is happening over here. That means internal pressure is more as compared to the external pressure, and the pressure is the force divided by the area. This I have explained in the previous video at the start of uh, the course of thermodynamics, to explain in the gaseous system what is the pressure, and pressure is the force per unit area. This is called the pressure. And you can easily calculate the force. Force will be pressure multiplied by the area. But here you have learned that what is the work. Work is the force into the displacement, and this is the force in case of the increasing number of the gaseous molecules, and this is going to displace this piston from this position to the this position, and this is the distance covered by the this displacement. Now here actually the two pressures are involved. One is the internal pressure, another one is the external pressure. So whenever there is the expansion, the internal pressure must always be greater than the external pressure. Then there should be a expansion over here. So let further solve the work. What is the work? As we have explained over here, this is the pressure is the force per unit area, and force will be equal to pressure multiplied by the area. So this is the force will be equal to pressure multiplied by the area, and here the sign is given over here is the minus, and this is the actually the external pressure. So what is represented over here, the minus sign, it is giving you explanation that the external pressure is less as compared to the internal pressure. So very simply as explained over here, but simply whenever the external pressure is less as compared to the internal pressure, that means this sign is representing the less, that means decrease in the pressure. And what is decreased, the external pressure is decreased as compared to the internal, and then there should be a expansion, and that is the logic behind the negative sign. So this is the reason why we are putting the minus sign with the P. So again, now we have previously explained that W will be equal to F into D. That means W, the work will be equal to force into displacement. And now you can replace the force, as the force is the minus P into A. So you can put minus P into A, and D is coming from this definition over here. So what is A and D? A is the area, which is the centimeter square. D is the distance, maybe in the centimeter. So centimeter square into centimeter, that would be the centimeter cube. And you know, centimeter cube is the, actually this is the volume. So that's why it is given A into D. This is called the volume. So what would be the, no, the final form of the work? Work will be equal to minus P. This is the minus P multiplied the V. And this is the represented by the delta, because there should be a change in the volume. Maybe there is decrease in volume or the increase in volume. There are the two conditions. So that's why it is, the volume is given with the change, and this change is represented by the symbol delta over here. And again, this is the capital delta. If there is a big change, we represent it by this symbol, that is called the delta. So in case of the expansion, so this is the generalized form. And so what is happening in the expansion? In expansion, delta V must be a positive value. Why it is positive value? Because this is the initial volume, and with the expansion, there is the increase in the volume. So when you subtract, this is the, maybe this is the V1, this is the V2, V2 minus V1, this must always be positive in case of the expansion. When this is the positive, and the positive multiplied with the minus, W will be the negative value. So you must always remember, and I will explain the next slide, the other parameters associated with the expansion work. But here, when delta V is the positive, W must be a negative value. So you can rewrite the first law of thermodynamics with the work here, we call it the pressure volume work. And this is the, we, you can replace the W with the this. So when you put the value over here, so delta E will be equal to Q minus P delta V. This is also the first law of thermodynamics in case of the pressure volume work, because this is associated with the gases. Now, what are the others? We have already discussed. The first point is, in expansion, change in volume must be a positive. That means V2, the final volume must be greater than the initial volume. That must be the first property of the expansion. When this is the positive, W must be a negative, as given, as explained over here. And W is the negative. That means this is the work done by the system. So there are the two work. One is the work done by the system, and the other one, in the next slide, I will explain the work done on the system. So when the sign is minus, that means it is the work done by the system. How you can explain? As it is given over here. So this is the system with the reaction, 6 moles are converted into the 7 moles. System is doing the work. That means it is expand. So this is the work done of this system. That's why when this is the work done of this system, this is having positive value, and this is would be the minus. That means when it is the minus, it is the work done by the system. So when there is the expansion, as explained before, for the expansion work, P external must be less than as compared to the P internal. So it must be having a minus sign. So this I have already explained. So what would be the Q? In this case, heat released by the system. So when heat released by the system, the sign of the Q would be the minus. So the next is the this work may be the contraction or the compression work, opposite to the expansion work. And simple example is given over here. 3 moles of hydrogen plus 1 mole of nitrogen, that means total moles are 4. And when these are converted into the product, 2 moles of ammonia are formed. So this is the explanation is given over here. First there was the 4 moles, now the volume is decreased, so this is called the contraction or the compression. So in case of the this, no, you must know this was the initial volume, and the volume is decreased. That means V1, this is the V2 minus V1. This is the less value. This is the more value over here. So when you subtract this minus this, you must have the minus value. So V change in volume in this case is the minus, in contrary to the expansion work. So when this is minus, minus multiplied by the minus, this is the formula, minus coming from the formula, and this minus I am talking about the delta V is having the minus sign. So minus multiplied by minus will give you the value of the positive. So W must be the positive value. So this is the work gained during the contraction, or you can say this is the work done on the system, because here there is the you may explain by using this equation, or maybe if you further apply a pressure over here, so that means this is going to be contract or compressed. That means this is the compression work, and in this case the external pressure is more as compared to the internal pressure. So all the parameter would be the opposite as I have explained in the expansion. So let's see, to conclude over here, what would be the explanation of all the thermodynamics parameter according to the first law of the thermodynamics in case of the contraction or the compression work. So first, delta V, in this case V1 is more than V2. This is the V1, and this is more than as compared to this. And when you can subtract V2 minus V1, of course you will get the minus value. When this is minus, as explained before, the work would be the positive, and the positive value is indicating that this is the work done on the system, and this is only be happened when external pressure would be greater than the internal pressure. That means external pressure, when it is greater, you can represent with the positive sign. So when there is the contraction or the expansion, in this case, heat is absorbed by the system. When heat is absorbed by the system, the Q value would be the positive sign, as I have explained before, and it is given over here. The temperature and internal energy is raised or increased in case of the compression. When it is increased, that means the Q must be a positive value, because the energy is absorbed by the system, and in this case W would be the positive. So this is all about our today lecture, and in this lecture I have explained the first law of the thermodynamics, its mathematical expression, and the other parameters or the explanation associated with the first law of the thermodynamics.